What if you had say, a long-running system, not just a question that needs one answer? Let's say you're handling
like
events,
a service.
events.
Right, events. It's something that, in principle, I do not think that it cannot be done, given the programming model, even though it's something that we haven't really focused. So our primary focus, as you might have understood from the slides, is analytics. But I definitely think that there's legitimate work to be done in that respect, to actually make MBrace more accommodating for service-oriented cloud deployments. I guess is the short answer. It's definitely something worth investigating, in my opinion.
Is there currently any provision for running unit tests
Unit tests.
in the cloud from Visual Studio?
That's an interesting question, actually. So if you saw in one of my previous slides, I did sort of show an MBrace.tests library, and this basically provides unit-based tests for sort of verifying certain aspects of any runtime implementation that you might provide for MBrace. And now the question is, how do you actually test that a specific MBrace runtime is well implemented? And the answer is we use MBrace, because we actually use the cloud programming model to sort of distribute assertions. So you can actually test assertions inside your cloud code, and since it works exactly like async, and async has integrated exception handling, if something goes wrong in one of the child computations, this will cause an uncaught exception that will bubble up across the distributed computation, and this will eventually be raised on the client side. So it's actually possible to define unit tests that test assertions across a big cluster, and if anything goes wrong, and it's just going to come back, as an assertion exception, basically. And we actually use that, and it actually works.
Right. Thank you.
That you definitely brought up a point I was going to ask earlier about the exception handling. Do you have to say show info and then it says, oh, here's your exception? Or?
Sure, yeah. It's actually failed because I closed Visual Studio, and that's sort of so the cluster state was hosted on the client process.
Right, that was exactly another question I was going to ask.
Yeah.
Let's say you've got something, and can you share your state to another window, or does it only exist on the one window? All of your, let's say you've got 4 machines running, and you want to be able to
self-hosted cluster implementation.
Right, let's say you've got a cluster of 4 A4 hosts out there, and you wanted to say, okay, 2 of us want to go work on this, attacking the cache and doing things with it, not just one person. Is there a way to share that or make sure it stays alive even if you close Visual Studio?
So, I mean, there are many ways I could answer this question. I guess we're not talking about the Thespian, so the self-hosted cluster implementation.
I'm not talking about Thespian, I'm talking about the cloud.
The cloud, okay.
So Azure.
So you're talking about faults, I suppose. You're talking about fault handling. What happens in case
Talk
somebody
about 2
dies.
things. Yeah.
Okay.
Let's start with the fault handling.
Okay. So if I open up my run method, this is really cool. So if I open up my run method, it does come with quite a few parameters, one of which is fault policy. And fault policy is actually a lambda, which takes an exception and number of times an integer, which indicates the number of times a specific work item has faulted, and sort of lets the user decide on whether it should actually retry the computation, that specific work item, or whether it should actually raise a fault exception, which is going to be caught by one of the parent work items. So this is our fault model at the moment. So if I were, I mean, it's difficult to demo at the moment, but if I sort of...
Can you divide by 0?
No, divide, so okay. So I guess fault is a bit overloaded in the context of the cloud. So if I do this, we don't consider this to be a fault. It's actually part of the programming model. mean, the exception is just going to bubble up on the client side. Obviously, I can just put this inside try with, so I can sort of you should never do that, but so this will prevent any exceptions from being from bubbling up on the client side. And the nice thing about this is that within the try body, you can actually define a distributed computation. So this try with clause actually can span multiple machines. And this is the coolest thing about this program model. But this is not a fault actually. This is just an exception. I mean, if I do this as, I'll revert back to the previous example.
There's many exceptions. Do you get like an aggregate exception, like a C# link?
No, it's just the exception that you raised. We don't really like aggregate exceptions, I guess. But I guess your question is more about what happens if a parallel workflow fails, if you get an aggregate exception then. Is that the question?
Yeah.
Yeah, in that case we do the same as async, so it's just the first exception that happens to fail. If you want to have an aggregate exception, you can just make each of the child computations try with and return a choice. So that's also an option. But I guess my main point here is that we don't really consider these to be faults. These are like exception values, essentially, because exceptions are being threaded through our cloud computation expression. So if I call show info in my process, the status is user exception. That's the term. If sort of you do a null reference exception, it's going to bubble up. If the library that you're referencing uses native code that is incompatible with the architecture that exists on the cluster, it's going to raise an exception that is going to bubble up on the client side. Everything is going to bubble up on the client side unless you handle it properly. But now the question comes to faults. I mean, what if I don't do fail with, but actually create a Stack Overflow? So when you Stack Overflow, you don't get a Stack Overflow exception. The process basically just dies. And in this case, this is actually a fault. This is actually what we call a fault in the context of MBrace. And in that case, of course, since the process dies, you cannot really use the normal exception handling computation expression niceties. You have to do something that's a bit more brutal, I would say. And in that case, we offer the fault policy. And you actually can specify this per computation by writing fault policy equals, and you have quite a few options: infinite retries, no retries, exponential delay, and with max retries. So I'm just going to do that. And this will actually, so if you have a Stack Overflow, it's going to retry a couple of times, and then it's just going to raise a fault exception, which again is going to bubble up through the parent process. So that's about it.
In the second question I was asking was, is there, you were pointing out that when you closed your Visual Studio, everybody else felt that and they couldn't handle it because your client was gone.
Okay.
And I don't care about the Thespian quite so much. I'm thinking more about Azure. Is there a way I can say set up a cluster and then share it to a couple of different windows or?
Oh no, I mean that's only a Thespian specific behavior.
Okay.
So I mean Thespian is really like a template implementation that we use for unit testing,
Sure.
and for reasons of simplicity, because it's like a really self-hosted local thing that does not depend on anything. For simplicity, we just host the cluster state on the client side, and the error messages that you saw are actually, these actually happened because I closed that specific FSI.
So here you've got, for Azure, you've got a context, the variable, your value context. Is there a way that I can move that to another window and use it?
So if I run cluster.show processes, if I correct it like this actually, you're going to see a whole lot of computations that I actually executed for this demo. I mean, this is the history of the demos that I ran today. If I now close Visual Studio and reopen it. All this state is actually being persisted on the Azure table storage. The assembly dependencies, all the computation information, and all the data is again persisted in blob storage. So if I provide the correct connection strings, which is happening here under the hood actually, I'll still get the same cluster.
So you'll get the same cluster when you say the config get cluster.
Yeah. I think it might be worth actually showing you.
So when you did like Cloudflow, the HTTP file, what actually came back? Was that?
You mean this guy?
Yeah. What actually came back there?
In this case, so in the case where I actually passed it the cache consumer, it actually returned a result of type persisted Cloudflow T. So this is a subtype of Cloudflow that is materialized across the cluster.
So so for instance, like Cloudflow of HTTP file by line.
Oh, right.
When that is.
Sorry. Yeah.
Okay, so does that, for instance, in that particular, would that end up getting like stored in blob storage, and then Cloudflow.map would reference that, or is that in memory?
No, I mean there's no. So in these 3 lines, when you actually run this, I mean you can't run it because Cloudflow cannot be run. You have to pass it to a consumer. So if I comment it out this line,
Right.
just called Cloudflow.length, there would be no blob storage operation whatsoever.
Right. No, I'm just simply asking how that process is that efficiently being processed is by. I'm asking basically is
how actual distribution is taking place?
Yeah.
Okay. So this actually depends on the underlying HTTP server. So you should be able to use a specific feature that allows you to sort of seek a specific part of the file.
So segmenting, so you can actually do. Okay. Wow. Okay. Nice.
Yeah.
Nice.
So I mean, there's no. So if you're asking if I'm actually downloading this on a single machine before performing the distributed computation, this is not happening. I mean, we just segment, as you said.
Interesting. Okay. So assuming the HTTP server doesn't support it, you'd actually be getting 3 separate, and then
You would have to download it locally and upload it to the blob storage, I guess. Which is
meaning that code specifically requires segmented downloading in order to
Yes.
work. Got it. Okay. What in terms of deployment of MBrace.Azure, do you simply need a account, or is it when you created that cluster? Was there anything else that you did before in order to set one up for MBrace?
What I did, and this is actually pretty recent code, which was contributed by Donsign. So actually, I did the same talk in San Francisco, and I didn't have this code. I actually had to open up a cloud service from Visual Studio, right-click, hit publish, etc., etc., etc. In this case, we have this management module in which you specify your local published settings file, your cluster name, the region that you want to deploy to, the VM size, the VM count, and optionally, of course, well, it doesn't work here, but let me show you. Subscription and the storage account, I think. And the actual provisioning is done through this management module. And this actually uses Azure.management under the hood.
Got it.
And your subscriptions and your pub settings file.
Exactly.
Right. Is there, when you deploy, is there a minimum count? One of them is like a supervisor node or something like that?
No, there is no supervisor node in this case. I mean, all the state is all the bookkeeping is being done by table storage. I mean, that's how we...
Got it.
Yeah.
Okay.
I mean, all the worker roles are blank slates. And actually, let me show you something else. I mean, if I type cluster.show workers, it's going to show me these 4 guys, right? But I mean, you don't really have to run this with worker roles. I can just type attach local worker, and we just zoom out. This is going to spawn an executable that basically runs the same code as the worker role does, and it's going to subscribe to my storage and service bus accounts. And after it's done a bit of work, I can rerun the same command.
So Thespian is packaged into.
Oh no, that's not Thespian.
Okay.
Thespian is a completely separate implementation.
Got it. Okay.
So you couldn't like mix AWS and Azure.
Yeah, and actually there was a really cool blog post by the guys at Alia CUDA. These are the guys that
the
provide
GPU guys.
the CUDA library for Azure. They actually distributed their computation using MBrace, but since Azure doesn't have machines with GPUs, they actually used AWS. So basically what they did was that they took the standalone executables and just subscribed them to a service bus and storage account.
Nice. So it's like it references back to Azure's storage. Yeah. Got it.
Mm-hmm.
Sweet.
Yeah, so now I have an additional couple of cores, which is not as good as the other ones, but
But that could be useful if you wanted to watch it run. You can watch it scroll in the window. You could...
yeah, of course you can. I mean, if I do cluster.workers, so these are worker refs, so I think it's the last one. Yeah.
Out of curiosity, like this worker rep thing,
Yeah.
like what is it? Can I run it on a server that I have at work or something?
Yeah, actually, you gave me the idea for the worker rep because we had this discussion last year, and you were like, "I want to send it to a specific machine," and we didn't have that at the time. So I was like, "Yeah, I need to do that."
Cool.
Yeah. So I mean, I can just run the computation there. So if I do cluster run and do cloud printfn, so obviously I'm going to introduce a side effect that is local to the specific process that it's being run, and I'm going to say target equal local worker. So let me just run this. So it's downloading. So you can actually see stuff here that you couldn't see on the previous demos. It's downloading FSI assembly. It's loading an app domain because it's the first time.
Yep,
and you get the side effect. So yeah.
Wow.
Pretty cool.
Any other questions?
That's one of the things I miss about Azure that I get on my current server thing is I can watch this stuff happen.
How do you run that? Like, how do you, is it, can you put it like a Windows service or something? Or?
This guy.
Yeah.
No, it's just a nyc. I mean,
Okay.
I mean,
It's referencing the storage.
I mean, we bundled this in the MBrace.Azure NuGet. So, I mean, if you loaded it with Packet, I mean, it just finds the.
But if you're not on a public internet, you can't get to it because you need the Azure storage blob.
I mean, as long as you have the connection strings, you can connect from wherever. And that's one of the nice things about it.
Can you point to the emulator?
Yes.
So theoretically, we could bypass Azure for like testing purposes.
Yeah, we use the emulator, both the storage and compute emulator for unit tests. So, yeah.
So you could abuse that.
Yeah.
And actually, Isaac did a really cool demo when he was presenting MBrace a few months ago. He basically passed around the connection strings to the audience and instructed them to sort of set up instances with his connection strings, and he was actually able to submit jobs.
So attach local worker to from
Yes. So he actually created a cluster from the audience laptops, and obviously somebody hiding in the shadows could just read everything from the local computer and upload it somewhere. So I don't think it makes a pretty cool demo, but it might have a few ramifications, I guess.
Do you have, within Cloudflow, do you have are there, like, I can't think of off the top of my head, but I would wonder if there would be like either constructs or actual functionality that requires targeting specific, like, is there any way to refer to like how you do either distribution strategy, or are there like targets on each of the, like, is there an optional target on in the Cloudflow's?
Not in the Cloudflow API per se. I mean, it abstracts away from all this stuff. I mean, under the hood, obviously, we do all those kinds of stuff.
Like, I can imagine there'd be at some point there, like, for some functionality, there would be a gather that would, like, if it would be required, that would have to, like, then what do you do? Where do you target, right?
It's not something that you can control from the outside of here.
Can you control like round robin strategy, or the VMs are like, you can't reuse existing VMs, right? Like, it's
What do you mean by that?
well, I can imagine having to, like, I could definitely think of instances where I'd want to use Cloudflow, but I'd want to use it against VMs that I've built to put stuff on top of there. I'm thinking for like interop purposes.
I'm not sure that I understand your question.
So imagine like, for instance, the Liakuda, right?
Yeah.
Okay, so like, bad example, but think of anything that requires like interop or native, right?
Right.
Which I can think of plenty of things that still, even without that example, like, I would want to, like, MBrace works. The only thing I can think that would miss. Well, I guess I can just do attached local worker as well. I'm trying to think of a reason. And then my point is that on that, like, if I could only attach, like, I'd want to make sure that the VMs that I'm running on has the functionality that I require.
Right. It's up to you to manage the cluster, I guess. That's the.
And what I'm asking is, does the
Okay, so if I'm getting this correctly, is that you have a heterogeneous cluster and you want to sort of restrict execution in a specific subset?
or I have extra functionality that I would need installed into the VM itself in order to.
I think in most cases we assume that the cluster is homogeneous. So if you have any additional dependencies, I think for the moment at least, a good approach would be to ensure that this functionality exists across the cluster.
Sure. Can I? The only thing I'm asking there is, can I specify a base VM for that?
Yeah. I mean, in terms of worker roles, we actually have an example in the starter kit that actually allows you to sort of pre-install Python.
Okay.
In the workers.
Perfect.
I guess
that's exactly what that is actually one thing I was thinking of. Like,
the biggest takeaway here is, I mean, if you're interested, do play with MBrace.starterkit. It has truckloads of material, and if you go inside the Azure folder, it has a pretty basic worker role implementation, which is just C# basically. It's like 100
right,
lines
but you
of code.
mentioned the other one was Python, so
Yeah,
I can see that.
I mean, that's the base implementation, but yeah, obviously you also have this guy, and I think this actually comes with a small PowerShell script that, just downloads Python with elevated permissions.
Right, okay.
So
That's
you also
that's
mentioned,
almost, yeah, that's close enough, I guess.
you also mentioned native dependencies. We actually have so I mean, there's many things you can discover here, and obviously I can't cover everything. But there is the possibility of, actually uploading native DLLs from the cluster. And I don't know why this is that here, but just drag it. I'm not going to run this, I'm just going to show you. So this is an example that uses math.net numerics. Math.net numerics is a managed library, but it also comes with an MKL component. So this is actually not a sample by me, but I don't. In this case, I just specify the path to the MKL NuGet package and just called .register native dependency on my cluster context, and this will make sure that any native DLLs are uploaded to the cluster as well as the managed dependencies. So this is a really cool demo because you can run a native job and also I think there's also a managed job. Right, a C-sharp job and a C-sharp job that does the same operation
Right.
as the native job, and you can actually sort of really detect the difference in performance.
Scale of 10 off.
Yeah. And while I'm at it, let me just show you the website. It's a badly designed website, but it does have quite a few tutorials. If you head to programming module, you can see many nice examples, and one that was actually added just yesterday was yeah, that's the one. So again, it's the house price examples, and it also shows you how you can visualize the data and use type providers to parse pretty much everything. Pretty neat. So yeah, please download the starter kit, visit the website, and find us on Twitter if you have any questions.